Thanks for having us. Thanks for sticking with us to the end of the day. And we appreciate your sacrifice. We know you all could be at Anton Thomas's talk on his colored pencil drawing, so we really appreciate that. We'll make it worth your while, we swear. All right, so yeah, I'm Lee France. I run the cartography team at onX Maps, and yeah, this is my coworker, Tony Cannistra. We're really excited to show you some of the work that we've been doing over the last year to develop our own high-resolution elevation tiles, and then how we've been utilizing those tiles for some really beautiful, highly detailed terrain renderings in our different onX applications. So throughout the talk, if you feel compelled to let out one of those NACIS, ooh, ah, nice, like please do. Like I tell my toddlers, I'm pretty sure it's bad for you if you hold it in, so. Anyways, let's jump into it. A little bit of context. People often gravitate to a platform like onX because they have a very specific way of exploring the outdoors. They want a tool that will help them be informed, get out there safely, and then return home again at the end of the day. And they may also be looking for inspiration, trying to find ideas and make plans about new places they'd like to check out in the future. So our map, therefore, needs to be very utility-driven, built to be incredibly useful in the field, but that doesn't mean that it can't be fun to use and look at as well. So at onX, we saw an opportunity to make our maps even more useful and informative through our representation of 3D terrain. It's standard practice now in mobile applications to render maps via map tiles, both vector and raster. And representing the landscape in 3D is achieved in a very similar way through RGB encoded raster tiles where a color can be translated to an actual elevation value. And the current offerings for elevation tiles just didn't really cut it for our needs. We needed more detail in rugged terrain so that someone could actually find a route up that mountain peak or find hidden paths or drainages while scouting for wildlife. So we took it upon ourselves to develop our own elevation tile set and then utilize that tile set to create incredibly detailed and beautiful terrain renderings in our applications. But I'll turn it over to Tony now to say all the really smart stuff about how we actually built those elevation tiles, and then we'll take a look at some.
Yeah, so for those of you who don't know, an elevation tile is just like a regular tile, but instead of a picture of like the ground from a satellite or an airplane, it's just a representation of the data that an DEM would be showing you for that given spot. We built these tiles, and you can get them like from Mapbox if you pay for that, or if there's other services as well that provide these. We decided to build our own because we weren't happy with the resolution we were getting from the providers that we were paying. So we said, why don't we just do it ourselves? I've got like 1 minute to tell you about 6.5, 7 months of engineering work. So I'm just going to run through some really quick bullet points here. We started with the MapSend data. If you worked there or worked there, you have this connection, thank God for you. This data set was amazing and was a great place to start. But 2016 was the last time that data was updated. And although land hasn't changed much since 2016, the available resolution of the data we have to represent the landscape has changed a lot. We've gotten a lot more detail. Specifically, the United States Geologic Survey has an amazing national program called the 3D Elevation Program, which for the whole country has 1 meter ground space distance DEM available data from aerial lidar. We pulled in that data and mosaicked it to the existing MapSend data. This, if you want to do this, go look up a software package called the NASA AIMS 3D stereo pipeline. Particularly the DEM mosaic tool is an incredible way for you to blend DEMs of different resolutions without even knowing that there was a seam in between them. Incredible software built originally for like blending DEMs taken by spacecraft, but works great for Earth too. And then we finally, this is really the majority of those 6 months is this last step, delivering performant map tiles to customers who are carrying these things around on their phones in like places where there's no cell phone service is really hard. And so we had to do a lot of tweaking and optimization to make sure that these tiles were small, that they maintained the amount of detail we needed to show the cartographic experiences that were important to our customers, and that they weren't wrong. So a lot of effort went into this, this component, and I'm happy to, if you find me afterward, give you more details on any of these things. Is this you now? Okay. Cool.
Awesome, thanks, Tony. All right, so yeah, there's a lot of derivatives that we can build from these elevation tiles that are relevant to our maps and our use cases. We can build maps for slope angle, which are really relevant for backcountry skiers, contours for our topo base maps, but the one that we really wanted to show today is hill shading. So previously we had generated a static raster hill shade, but this time we wanted to leverage Mapbox's ability to dynamically render hill shading on the fly. This ends up giving us some knobs to turn in the style sheet for the look of the hill shade by assigning colors for shadows, accents, and highlights, and then we can actually adjust those colors throughout the zoom and across our product suite of maps. It also allows us to dynamically render an angle of illumination based on the map user's field of view. So let's take a look at that now. I really hope this video works. Please. This does not bode well. There we go. Come on. There we go. All right, so at a low zoom view, we're actually using a Edward Earth-derived hill shade that's just raster-based. And then as we zoom in, it transitions to our more typical just 2D topo. And as we move it into 3D, it just really doesn't provide the level of detail that we need for our users. So now when we turn on this new feature using these high-resolution elevation tiles to dynamically render the hill shade, it just starts to bring out so much incredible detail in the landscape that are really relevant for the places our users are going to explore the outdoors. As we can see that here in these beautiful mud flows on Mount St. Helens. All right, we'll zoom to another location here over in the Midwest. This is a spot that's maybe a little more relevant to our hunter use case. You really have to be an expert to read contour lines in this flatter landscape to pick out subtle terrain features. And it's often just really covered in dense tree cover, so they don't have a good sense of what's going on under the ground. But when we turn on this 3-depth-based elevation data, so much detail starts to come out for hidden drainages, small depressions, ridge lines, things that are really relevant for them while they're out in the field. So God help any whitetail out in the Midwest. Another location near and dear to my heart here in Sandpoint, Idaho. This is a hillside where we're actually developing some new cross-country ski trails with the local Nordic club. And as we turn this on, we see this hillside is mostly illuminated from the northwest, but then as we rotate it around and we get that dynamic angle of illumination, so many new hidden features start to appear in the hillshade, like hidden roads or flat landing piles, things like that. All right, we'll take a look at another cool mountainous example here in Glacier National Park. So again, the typical map here in 3D without that dynamic shading, it just doesn't really give us the level of detail that we would want to understand this landscape. When we turn that on, it just brings so much of this to life. And as we rotate the map around, we're always getting that optimized balance of shadows and highlights with that dynamic shading. All right, we'll zoom out and check out another spot here in Colorado. This is the Maroon Bells, just south of Aspen. Another spot, really beautiful area to hike, very popular for folks using an app like onX Backcountry. And then as we turn on that dynamic shading again, it just really brings the mountains to life. You could like genuinely use this to maybe even find a path up these mountain peaks because so many subtle little mountainous features are illuminated, ridge lines, etc. And then we'll just check out one more spot while we have time. This is the Grand Tetons, always one of the most fun to look at in a topographic map. And then as we zoom in, we'll switch on that high quality topo. And again, it's just bringing that to life. Got a little excited on the zoom. And then we can see features like boulder fields, glacial moraines, you know, the trail running up the side of that mountain. Everything is just like really get a sense of what you're going to find on the ground. Plus, it's just really helping with that inspiration piece of our product as people explore this map and get inspired about the places that they might one day want to go. Oops, it's going again. There we go. All right, that is our talk. Yeah, just a quick one, but I think we might have time for a few questions if anybody has any. Sure.
I was just curious, it looked like you were just draping the topo over the hillshade. Can you do it with the imagery too, or have you decided that the registration isn't good enough?
We did explore that as a potential avenue of combining it with some imagery, and it does look really cool in certain places, but our imagery is just kind of inconsistent. Like some places it might be like really well illuminated and there's no shadows in the imagery, and then other places it's totally different. So we haven't found like a really great way to bring this to our imagery product yet, but it is an area that we've been exploring because it does look really cool in certain situations. In the back.
Yeah, so you mentioned that you weren't satisfied with the commercial providers' terrain, and you used that to build your own. But like, are you using the same tile sizes or more zoom levels? What's the major difference in the higher quality or the big tiles?
Cool. Tony, do you want to answer for me? Sure.
Yeah, I mean, so a lot of the providers just have a slower update cadence on the new releases. For example, the USGS 1 meter data sets are being released like every week, and we wanted to stay on top of that for our customers to be able to incorporate it into the product as quickly as possible. And when we sort of outsource that to another organization, we don't have control over that. So we wanted to bring that in-house for that reason. And then also, the zoom level question is one that we also needed to manage on ourselves. The provider we were using did not provide enough zoom levels to encompass the source data's source resolution, so we needed to push the number of zoom levels deeper. But it also gave us control over some of the parameters of the tiles that weren't working for us in terms of a data delivery concept. Like, we need these tiles to be available on someone's phone offline, and we don't want those tiles to like take up 90% of their phone storage. So we did a lot of work to optimize the file formats and the encodings that we used for the DEM data to enable them to fit better on somebody's phone storage than we would be able to get with the tiles we were purchasing.
How come you manually turn it on? Why not just have that come on?
That was really just for the purpose of the demo. I think it probably will be, when we do launch it, it will just be built into the product like that. Yeah. Here in the green.
What kind of efforts did you make to truth the ice and the water, and over time, those change, obviously?
Do you mean like within the shading itself, or just the other vectors that you see on the base map?
Yeah, on the map.
Yeah, I mean, we build like a nationwide map, so we aren't able to go out and be ground truthing that stuff as much as we would love to be doing that. So we're always kind of continuously updating that data on our end, but yeah, we're usually, can only be as accurate as the places we're getting the data from when it comes to that sort of thing.
You have slope angle shading to go along with the high res?
Yeah, one of the amazing things about building your own DEM tiles is that you get to build all sorts of other DEM-derived products on top of it that match the resolution of the source data that you've built into your DEM tiles. So yeah, we build our slope angle, we build our slope aspect, we build our contours, we build our static hill shading, we build our elevation lookup service, all from this exact same tile set. So when we update it in one place, all those downstream services are pulling from that same spot, and so they can actually benefit from a single update in one place to pull in that updated data. Yeah.
Jake?
Sort of a follow-up question on that. When you say that you're building these derivative products from your DEM tiles, are those the literal RGB DEM tiles, or do you have something that's higher bit depth or has like a margin around the tile?
That's a good question. We do build them from the RGB encoded tiles, but we have different parameters of encoding for different zoom levels. And so we can maintain more of the source resolution at the higher zoom levels than we do for the lower ones, which we generalize a little bit more. And so when we build some of these derived products, we rely on the higher resolution data to build them. We don't sort of like have a one-to-one match between, if we're building a Zoom 13 slope angle tile, we may not use the Zoom 13 DEM tile to build those slope angle data. We may push it a little bit further and then back out the tiles from that. Yeah.
One more? Sure.
Base map, the spot elevation figures you use, are those DEM based, lidar based, or couple based for your spot elevations in your base map?
Like on the peaks.
Oh, those are just derived from the GNIS right now. We haven't gone down the road of trying to manually create our own peak locations yet. Good. Okay. Thank you, everyone.
Thank you, Lee and Tony. That was awesome.